Let us get into more generalized concept of vectors. So we introduce another entity which is called tensor. We say that a scalar is a zeroth order tensor. So that means to say that the scalar is a set of 3 power 0 components, which is equal to 1. So in order to define a scalar, we just need one component, and that is magnitude. Then we say that a vector is the first order tensor. So in order to define vector components, we need 3 power 1 components. Or in other words, a vector has 3 power 1 components, and that is 3. Then we have another entity which require 3 power 2 components. That is the second order tensor. And this can go on and on. So the question comes that why do we need a second order tensor? Quantities such as temperature and mass, densities, they require only magnitude. So scalar is good enough for them. We can define it in a scalar space. Quantities such as accelerations, forces, displacements, they are first order tensor, and a vector space is a space which can define these entities. But in structure mechanics, we have some other quantities which are called stresses and strains. They require 9 components because we normally take a cube which has got 6 faces, and every face has got 3 forces or 3 displacements. But due to equilibrium, those displacements of forces come down to 9 distinct forces or displacements. In order to define a stress or strain, we need 9 distinct components. So in the case of a body which is subjected to variety of loads and that is supported, we take a reference surface. After this, we assume that the reference surface is made up of infinite elements. Each element is in the shape of cube. At each and every face of this cube, we have 2 shear and 1 axial variable. So altogether, there are 18 variables. Equilibrium of the element reduces this 18 variables into 9 variables. By equilibrium, we mean summation of all the forces and summation of all the moment about each and every axis is 0. So that brings the number of variables down to 9. So these variables can be either stresses and correspondingly strains. So in order to define such sort of entity which has got 9 distinct components, we need a higher order or a generalized vector, and that vector is called tensor. A second order tensor will have 3 power 2, which is 9 components, and a second order tensor will define a stress or a strain. Tensors act on vectors and give us another vector. So imagine we have bunch of vectors. In this figure, we can see bunch of vectors arranged in a form of sphere. So from point O, which is the center of this sphere, a vector bunch is radiating out. We take one particular vector out of the whole bunch, multiply that with the tensor t, and t is shown as tilde, which means that this is the second order tensor. In case of vector, we show it as a straight underline. Once this is multiplied with the tensor, we get another vector, which for example is shown in blue. So this bold red vector is multiplied with the tensor and we get another vector, blue one. If this bunch of vectors were arranged in a form of a sphere initially, after multiplying each and every vector of this bunch with the tensor t, we get something in the form of ellipsoid. So ellipsoid, it looks like an egg. So as you can see, some of the vectors will be either deformed or some will shrink. That in the case of a certain structure which is subjected to some loading, instead of taking a cube, we can consider this as a sphere. So we say that that sphere is actually containing bunch of vectors. Imagine this is the condition of this bunch before application of the load. So for example, this bunch can show initial displacements. So this sphere can be a particular point within a structure, and all these vectors that they show initial displacement. Once we apply loading, then this sphere becomes an ellipsoid. So after application of the load, this sphere will either extend or it will get shrunk. So this is another concept of understanding 3 power 2 tensor. Please note, when a particular vector within this sphere is multiplied with the tensor t, its length and direction will change, and which will make sense. If this is a displacement, initial displacement at a particular point within a structure, after application of the load, this particular displacement in a certain direction will either increase or will either decrease. So we can also say that if this box is the arrangement before application of the load, after application of the load, the box shape will change. The same is true if we consider this box as a sphere. So initially, if we had a sphere, after application of the load, the sphere will be changed into a ellipsoid, which looks like an egg. The tensor t operating on U is also called as a linear map. So if we want to visualize it, we can say that if we have a 2 by 2 real system space or a 2D real space, and we define a vector u within 2D, after multiplication of the tensor, imagine that tensor is a 2 by 2 matrix. So the position of this u will change. So u will either get extended or shrunk in magnitude, and its direction will change. That's why I have written that linear map transforms the input vector. This tensor, it is sort of a transformation. It transforms this u vector into v. Now, just like a vector and a scalar field, we have got a tensor field. A tensor field will show a solid within a space. So in the case of a scalar field, we can have a 2D curve. So this curve is a function of x1 and x2. In order to convert this curve into 3D, we would have 3 dependent variables, which is x1, x2, and x3. The problem comes that we are not able to visualize that within the available 3 axes. So in the case of a solid structure, which is made up of 3 independent variables, x1, x2, and x3, then the practice is that we show that as a contour map. So this structure, which is a solid, it is shown in a 3D Cartesian coordinate system, and the stresses or strains within this system are shown by contours. Please note that stress and strains, they both are second order tensors. We can also have a tensor as a function of a position, just like the scalar field and vector field. And we can have a t of x is equal to t tilde of x. So this is a function of x.